Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the Lewis theory of acids and bases. So according to Lewis, acid is a substance which is capable of accepting an electron pair and forms a coordination covalent bond. Generally, a coordination covalent bond is represented by an arrow. So simply, acid is a substance which accepts a pair of electrons. That means, in other words, Lewis acid can be defined as an electron deficient compound. So what is meant by a Lewis acid? It is an electron deficient substance. Coming to the examples of Lewis acids, generally Lewis acids includes several categories. So let us consider the types of Lewis acids. So coming to the types of Lewis acids, generally electrophiles. That means simple cations will act as Lewis acids. So coming to the types of Lewis acids, generally electrophiles. In other words, they can be called as simple cations. So electrophiles or simple cations will act as Lewis acids, and the best examples includes H plus, Na plus, Mg plus 2, Zn plus 2. So simple cations are good examples of Lewis acids. In the similar way, the electron deficient compounds will act as Lewis acids. So electron deficient compounds, that means the compounds in which the octet configuration is not completed. So generally the best examples includes boron trifluoride, aluminum trifluoride, iron trifluoride. All these are good examples for electron deficient compounds. So electron deficient compounds also acts as the Lewis acids. In addition to electron deficient compounds, molecules in which the central atom, especially we can consider the molecules in which the central atom can expand its octet, can act as Lewis acids. So central atom can expand octet configuration, acts as Lewis acids. So best examples are silicon tetrafluoride, silicon tetrachloride, etc. Especially when you consider silicon, it consists of empty d orbital. With the result, it is capable of accommodating more and more electrons. With the result, if you consider the molecules in which the central atom can expand its octet, they can act as Lewis acids. At the same time, if the molecules contains double bond between the heteroatoms, so if the double bond is present between the heteroatoms such as CO2, SO2, they can also act as Lewis acid. For an instant, let us consider the structure of CO2. So a double bond will be present between the oxygen atom and the carbon atom. So between oxygen and carbon, oxygen atom is more electronegative. So the electron pair is more attracted towards the oxygen atom. With the result, oxygen acquires partial negative charge, whereas carbon acquires partial positive charge. So this carbon is capable of accepting an electron pair and hence it can act as Lewis acid. In the similar way, the carbonium ions. Carbonium ions means if the positive charge is carried by the carbon atom, then they are called as carbonium ions. They are also electron deficient compounds and hence they can act as Lewis acids. At the same time, there are several elements which contains only 8 electrons. So elements with 6 electrons are capable of accepting electron pair and hence they can act as Lewis acids. And the examples are oxygen, sulfur, selenium, tellurium. These elements contains only 6 electrons in the outermost orbit. With the result, they are ready to accept the electron pair and hence they can act as Lewis acids. So simply Lewis acids includes electrophiles or simple cations, electron deficient compounds, molecules in which the central atom can expand, octet, molecules containing double bond between the heteroatoms, carbonium ions, and the element with 6 electrons will act as Lewis acids. Next, we will discuss about the Lewis base. So, what is meant by Lewis base? Lewis base means a substance which is capable of donating an electron pair and capable of forming a coordination covalent bond. So Lewis base means a substance which is capable of donating the electron pair and forms the coordination covalent bond. So simply you can call Lewis base as an electron rich species. So Lewis base is the electron rich compound. So there are several types of compounds which can be called as Lewis bases. Let us see the types of Lewis bases. So coming to the types of Lewis bases, generally they include simple anions. So simple anions can be called as Lewis bases. So simple anions generally includes OH minus, Cn minus, Cl minus. So they can act as Lewis bases. In other words, we can also call them as nucleophiles. So nucleophiles are the best examples of Lewis bases. At the same time, generally the molecules which contains at least one lone pair of electrons will act as Lewis bases, and the best examples includes ammonia, water, etc. So when you consider ammonia, it consists of one lone pair of electrons on the nitrogen. And when we consider water, oxygen contains two lone pairs of electrons. And also amines can act as Lewis bases since the nitrogen atom contains one lone pair of electrons. At the same time, when we consider molecules containing multiple bonds between the carbon atoms, they can also act as Lewis bases since these two atoms are having same electronegativity value, and hence if at all an electron deficient compound is available, these compounds can donate electrons. So substances which are capable of donating electrons can be called as Lewis bases. And the best examples are ethylene, that means CH2 double bond CH2. So, compounds which contains double bond between the two carbon atoms can act as Lewis bases. At the same time, we can also consider carbon ions as Lewis bases. So, carbon ions means the substances which contains negative charge on the carbon atom. They can be called as carbon ions. If the negative charge is carried by the carbon atom, they can be called as carbon ions, and they are electron rich species, and hence they can act as Lewis bases. So is it clear about the types of Lewis bases? Next, we will consider the neutralization reaction. So coming to the neutralization reaction means generally it involves the formation of coordination covalent bond between an acid and a base. Let us see one best example, that is, so whenever ammonia is available, it is capable of donating the lone pair of electrons, and whenever if we consider boron trifluoride, it is an electron deficient compound. So ammonia is Lewis base, whereas boron trifluoride is Lewis acid. So ammonia is capable of donating a pair of electrons to the boron trifluoride. Then it results in the formation of a coordination covalent bond between the ammonia and boron trifluoride. So it is good example for Lewis acid base neutralization reaction. Here the product which is formed during neutralization reaction is called as salt. So what is meant by Lewis salt? The addition product formed during the neutralization reaction is called as the salt. So ammonium boron trifluoride is called as the salt. So is it clear about the neutralization reaction and Lewis salt? This is about the Lewis acids and bases. Let us see what are the merits of Lewis acids and Lewis base theory. So coming to the merits of Lewis theory, it explains the acidic nature of electron deficient compounds. So especially it explains the acidic nature of electron deficient compounds such as BF3, AlCl3, etc. Not only it explains the acidic nature of electron deficient compounds, but it explains the acidic nature of various substances and also the basic nature of maximum category of substances. So it beautifully explains the behavior of acids and bases. So it explains the behavior of acids and bases. These are the merits of Lewis acids and base theory. So coming to the limitations, there are several limitations of Lewis theory. In general, it explains acid is an electron deficient compound and base as an electron rich species, and both are capable of forming a coordination covalent bond. But it could not explain the relative strength of acids and bases. So Lewis theory could not explain the relative strength of acids and bases. In general, it could not explain the neutralization reaction of simple acids and bases. So let us consider the neutralization reaction of HCl and NaOH. So it is the well-known neutralization reaction which do not involve the formation of coordination covalent bond. So in general, simple acid-base reactions do not involve the formation of coordination covalent bond, which is against Lewis theory. At the same time, generally the well-known acids HCl, H2SO4 and also HNO3 do not form coordination covalent bonds, but they are the well-known acids. So, according to Lewis theory, what is meant by an acid? Acid is an electron deficient compound and it is capable of forming a coordination covalent bond. And coming to the speed of the acid-base reaction, generally the acid-base reactions are very fast. But coming to the Lewis acid-base reaction, it involves the formation of coordination covalent bond and hence the Lewis acid-base reactions are very slow, which is against the simple acid-base reactions. So these are the limitations of Lewis theory of acids and bases. Is it clear about the Lewis theory of acids and bases, students? Let us discuss about the multiple choice questions based upon the Lewis theory of acids and bases. Which of the following is an Lewis acid? So according to Lewis, what is meant by an acid? Electron deficient compound is called as Lewis acids. Okay, coming to the first option, ammonia. It contains lone pair of electrons, so it is electron rich species. It is not an Lewis acid. Coming to the second option, BCl3, it is an electron deficient compound, so it is the Lewis acid. Third option, it contains oxygen, so two lone pairs of electrons are present. It is not a Lewis acid. CCl4 is also not a Lewis acid. So option B is the right answer. An electrophile is. So as we discussed just now, electrophile means electron deficient compound. So it will act as Lewis acid. CO2 is an example of. So CO2 means here we have to consider the detailed structure of CO2. Here the double bond is present between carbon and oxygen atom. With the result, oxygen carries negative charge and carbon carries partial positive charge and hence it can act as Lewis acid. So carbon dioxide is an example of Lewis acid. Ethylene can act as. So ethylene means here also we have to consider the structural formula of ethylene. So a double bond is present between the two carbon atoms. Then what happens? It can act as electron rich species. So electron rich species can be called as Lewis base. So ethylene can act as Lewis base. Which of the following is the strongest Lewis acid? So whenever if we consider boron trihalides, so here 4 boron trihalides are given. So the strength of the boron trihalides increases as the size of the anion increases. So here boron triiodide is the strongest Lewis acid. Which of the following compound is a Lewis acid? Lewis acid means definitely it is an electron deficient compound. So boron trichloride is the electron deficient compound. Here in the third option, nitrogen is present. It contains lone pair of electrons. So even if we consider phosphorus trichloride, it also consists of lone pair of electrons. And coming to the option D, its octet is completed. So option B is the right answer. Amines acts as. Amines means, let us see one example. Let us consider the primary amine. It contains nitrogen. So whenever the nitrogen atom is available, it carries lone pair of electrons. So it can act as electron rich species. So it is capable of donating the electrons. That means it can act as Lewis base. So amines will act as Lewis bases. Which of the following is a Lewis base? Lewis base means electron rich species. It is capable of donating the electron pair. So when we consider option A, B, C, all these are electron deficient compounds. But coming to the option D, it carries oxygen. So two lone pairs of electrons are available. So sodium ethoxide can act as a Lewis base. Which of the following molecule is not a Lewis base? That means which of the following is a Lewis acid? So Lewis acid means electron deficient compound. Coming to the first option, water carries two lone pairs of electrons. BF3 is an electron deficient compound, so it is good example for Lewis acid. So when we consider option C, ammonia, it carries one lone pair of electron. And coming to the option D, it is carbon monoxide. When we consider the structural formula, a triple bond is present between carbon and oxygen. Here carbon carries a pair of electrons and also oxygen carries a pair of electrons. So with the result, it can act as Lewis base. So in this case, option B is the right answer. Which of the following is an example of Lewis acid? Lewis acid means electron deficient compound. So first, in the first option, oxygen is present. That means two lone pairs are present. So it will act as Lewis base. So coming to the second option, that is iron trichloride. So it is an electron deficient compound. So it will act as the Lewis acid. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.